Hello, it's Professor Stephen Eshuba, and I'm here to help you out with some hands-on examples of how to set up the modeling of the atmosphere and radiative balance in Excel. So I've got this file open in Excel, and I've already entered in these text fields. And so I entered in a value of 0 for the temperature just to start with for the no atmosphere case. And if I want to convert that to Fahrenheit, then what you do is you'll say you'll put in an equal sign, and you say, well, it's equal to the temperature in Celsius. And now you have to convert that to a scale, so that would be times 9 divided by 5, and add 32. So that's that. Now, because the way this is set up is if I change the temperature in Celsius, it'll automatically change the temperature in Fahrenheit. I'll set that back to 0. Similar thing to converting to Kelvin. You have to start off with an equal sign, and it's equal to temperature in Celsius plus 273, and I'm just going to hit return there. So there's that. Now for the long wave out, we have to enter in a more complicated formula. So as you may recall, that what we're entering in there is the Stefan-Boltzmann formula, sigma times t to the fourth. That's basically the surface emitted by the long wave emitted by the surface. So sigma times t to the fourth. So I'm going to say, well, that's equal to sigma, which happens to be 5.67 times 10 to the minus 8. That's sigma times the temperature, and we need that temperature in Kelvin. And the way you raise it to the fourth power is this way. So there we have the short wave in, which is this value, 163.3. The long wave out, which for this particular temperature is that. But of course, if I change that temperature now, that will also change. And oh well, we finally need to have an imbalance. Well, that's pretty straightforward. What I want is the energy coming in minus the energy going out, which in this case is just that long wave. So you can kind of see that there's an imbalance here, that there's more energy going out of the surface of the planet than there is coming in, which means that this planet will cool down, and as it cools down, it will get closer, presumably, to radiative balance. So, for example, if I typed in minus 20 there, you can see that this is closer to radiative balance. Now, one last thing is to use Excel to figure out the correct temperature, and for that we're going to go to Tools and this thing called Goal Seek. And what we want to do in Goal Seek is I'm going to set cell B11. I want to have that a value of 0 because I want it to be in radiative balance. And how am I going to change it? Well, I'm going to use that by changing the temperature in Celsius. And so let's see how that goes. Well, look what a great job it did. It got very close to radiative balance, and the result is that a temperature of this planet is very cold to be in radiative balance, minus 41 Celsius. Well, that's no surprise because there's no greenhouse warming on this planet. Now, for the rest of the exercise, you're going to set up similar models. Here in Model 2, we've just added that back radiation bit that we see here, that back radiation. So Model 2 has some greenhouse warming in it. And Model 3 also has back radiation, as you can see, plus the latent heat term, which I'll show you here. It's this latent heat term. You have to make sure you get the signs right on that when you do the radiative balance, because this is leaving the planet. And let's see, and then we have one more, Model 4, which is short wave in, long wave out, back radiation, infrared, greenhouse effect coming down, latent heat going out away from the surface, and thermal heat going away from the surface. Now, I've just set all these to initial temperatures of 0, but you're going to want to use Goal Seek to find on each one of these to find out where the imbalance is 0 to come up with a temperature for each one. Okay, that's the exercise.